Hi, welcome to my video on the derivative quotient rule, and this is the review of the unit. And as in all my reviews, you can treat it as a test or a quiz where you can score each question and total up the page and add the pages together to see what mark you're going to score out of 33. Here we go. Number 1, find p prime of x if the p of x equals 3x squared minus 4x all over 2x plus 4. Both of them are polynomials, and this is the quotient, this is the f, and this is the g. And how I write it, I go f prime g times f prime times g, subtract f times g prime all over g squared. So what we'll do is we'll take the first one and I'll write it down without doing the derivative. So there's the derivative of f times g, subtract f, which is 3x squared minus 4x times x plus 1 derivative all over g, which is 2x plus 1 squared. So let's do the derivative of f. 3x squared is 6x. Derivative of negative 4x is negative 4. And we have 2x plus 1. Subtract 3x squared minus 4x. Derivative of 2x plus 1 is 2. Derivative of 2x is 2. Derivative of, that's a plus 1 right there. Plus 1 is 0. All over, and we no need to expand it out, just leave it as x plus 1 all squared. And we do the FOIL on first one, so we do the multiplication first, so let's do subtraction, let's do the FOIL, and then we'll do the multiplication and subtract after by PEMDAS. So 6x times 2x is 12x squared. 6x times 1 is 6x. Negative 4 times 2x is negative 8x. Negative 4 times 1 is negative 4. And now we multiply 2 by 3x minus 3x squared minus 4x gives us 6x squared minus 8x all over the denominator, x plus 1 all squared. And we have to subtract, so we can put a 1 here if we want, or we can add on the opposite. So, I could have simplified in here. I'll do the simplification at the same time. So 6 minus 8 is negative 2. And we're multiplying by negative 1, we're adding on the opposite. So it's a negative 6x squared plus 8x all over 2x plus 1 squared. And when we simplify, descending order, 12 minus 6 is 6x squared. And we got negative 2x, 8x is plus 6x minus 4 all over 2x plus 1 all squared. So that's the derivative. And we got 4 marks, so it's almost like 4 steps. 1, 2, 3, 4. And if you simplify, you get down to here. So there's a mark here and a mark, so 4 marks altogether. Find h prime of 1 if the h of x equals ln x over 3 to the x. So this is the f and this is the g, and again I always write it out. So f prime g minus f times g prime all over g squared. So the h prime of x is the derivative of f, so it's ln x derivative times the g minus ln x and 3 to the x derivative all over 3 to the x squared. So that gives us the derivative of ln x is 1 over x times 3 to the x, and the derivative of 3 to the x, that's an x, derivative of 3 to the x is 3 to the x ln 3, and this is 3 when you square this, is 3 to the 2x. And we're going to put in, now since we have that done, what I'm going to do is do the ln prime of 1. So I'm going to put 1 in the place of x now. So 1 over 1 times 3 to the 1 ln of 1 times 3. So x is 1. So x is 1. Oh, this is 3. So we simplify that. So that's 1 over 1 is 1. 3 to the 1 is 3. The ln of 1 is 0. So that's 0 times 3 ln 3. And that's 3. 2 times 1 is 2. 3 to the 2 is 9. So that becomes 3. And 0 times that is 0 over 9. So that's 3 over 9, or 1/3. So there's 5 marks for this. So if you have, go 1, 2, 3, 4, 5. And total up the page, and the page is out of 9. Hopefully everything is going well. Number 3. The b of x equals root x plus 1 divided by root x minus 1. Find the b prime of x's derivative. So notice that this, again, this is an f and a g is a division. So it's f prime g minus f g prime over g squared. So b prime x, so it's the root of x plus 1. That's gone over too far there. That's the derivative of f times g minus f times the derivative of g all over root x minus 1 squared. So the derivative of root x is 1 over 2 root x. Derivative of 1 is 0 times root x minus 1. Subtract root x plus 1. And again, the derivative of root x is 1 over 2 root x. If you have it memorized, I do. And derivative of negative 1 is 0. All over root x minus 1 squared. And so we multiply here. I'm just going to notice that this 2 root x will end up as the denominator here, and it'll end up as the denominator here. So I'm going to write down root x minus 1 over 2 root x. Subtract root x plus 1 over 2 root x divided by root x minus 1 squared. So since we have a complex fraction, but I can add these two together first if I wish, because they're the same denominators. So if I go 2 root x, which is your denominator of both of these, so that's root x minus 1. We're going to subtract root x plus 1, so that's the negative of root x is negative root x, and the negative of plus 1 is minus 1, and that's root x minus 1 all squared, and the root x's cancel out, so that gives us negative 2 over 2 root x divided by root x minus 1 squared. And the 2's cancel out here, so that's 1 and 1. So that's negative 1 over root x divided by the root of x minus 1 squared. And this is a complex fraction, so let's put it over 1 here. So that's negative 1 over root x. So we're dividing, so we multiply by the reciprocal, so it's 1 over root x minus 1 squared. And when you multiply that out, you get a negative 1 over root x times root x minus 1 squared, which is the derivative of this expression here. And there's 8 marks here. So what you can do is give yourself 1, 2, 3, 4, 5, 6, 7, 8. Perfect. If you get the right answer, give yourself 8 marks. Okay, let's do another one. Find the equation of the tangent or tangents to y equals x plus 1 over x minus 1 if the tangent is parallel to this line. Notice this is a linear. Negative 2x minus y equals 3. So again, to get the equation of the tangent, we need to get the slope of the tangent, and the slope of the tangent is the derivative of this expression here, derivative of y in terms of x. But the tangent is parallel to this line, so the line is negative 2x minus y equals 3. Parallel lines have the same slopes, so parallel lines have equal slopes. So let's find the slope of this line. Solve for y. Negative y equals 2x plus 3. Divide by negative 1. And we get y equals negative 2x minus 3. So the slope of this line is negative 2. So the slope of the tangent, so the slope of the tangent is negative 2. So let's go and find the derivative of this function, and the derivative will be the slope of the tangent at any point. So here we go. So let's take the y equals x plus 1, x minus 1. Again, this is a division, a quotient. So we do the, so this is f and g. So we have f prime times g minus f times g prime all over g squared. So y, the derivative, which is y prime or d dx. If we do d dx, which is the same as saying y prime, so it's x plus 1 derivative times g minus x minus f, there's f, times derivative of g all over x minus 1 squared. So y prime, derivative of x plus 1 is 1. X minus 1. Derivative of x minus 1 is 1. Remember, derivative of x is 1. Derivative of negative 1 is 0. And that's all over x minus 1 squared. And that becomes, do the multiplication first. We can do the multiplication, and we can take the 1 and put it right here. So 1 times x minus 1 is x minus 1. Negative 1 times x minus negative x minus 1. Negative times negative 1 times x, negative 1 times positive 1, negative 1, all over x minus 1 squared. And that becomes, the x's cancel, negative 2 over x minus 1 squared. And so y prime is equal to the slope of the tangent. And that be the case, the slope of the tangent right here is negative 2. That means that negative 2 over x minus 1 squared is equal to negative 2. So that's negative 2 over 1. And because both numerators are equal, that means the denominators are equal. I could cross multiply, but I don't have to. So x minus 1 equals plus or minus the square root of 1. So x equals 1 plus or minus square root of 1 is 1. X equals 1 plus 1 or 1 minus 1. So x equals 2 or 0. So let's look at where x equals 2 to get the equation of the line. So if x is 2, let's put the 2 back in here. So y equals x plus 1 over x minus 1. So this is when x is 2. So y equals 2 plus 1, 2 minus 1. So that's 3 over 1, or 3. So that line, so that point, when x is 2, y is 3. When x is 2, y is 3. So we'll sub that in to the equation. So y equals mx plus b. So this is x and that's y. And the slope is, we found out the slope to be negative 2. So if the slope is negative 2, which we found here, so we have y is 3, so 3 equals negative 2, and x is 2 plus b, so 3 equals negative 4 plus b, so b is 3 plus 4, so b is 7, so the equation is y equals, slope is negative 2 times x, and b is 7. So what about when x equals 0? So if x equals 0, let's put 0 into this equation, and 0 plus 1 all over 0 minus 1, it's 1 over negative 1, or negative 1. So this point is when x is 0, y is negative 1. So the equation is y equals mx plus b, and just make sure this is x and y. Again, the slope is negative 2, y is negative 1, slope is negative 2, x is 0, so we get negative 1 equals 0 plus b, so b is equal to negative 1, so y equals slope mx minus 1. So that's the two equations that will be parallel to this line, because the slope of this line is negative 2, slope of these lines are negative 2, and they have different y-intercepts. Again, a different question, and there's 11 points here. So if you found the slope, you worked out the slope be 2, and then you said the slope is of the tangent is negative 2. You worked out your derivative, and you got here, so you give yourself a mark. And if you worked it down to here, you give yourself a mark. And if you let them equal, and you solve the two of them, as far as here, and then, so these are the marks going down through. 11 marks altogether. Total up your score out of 11. And one more question. Find ddx of this expression. So we have x squared y cubed over 3x plus 2y. And again, this is a quotient. This is f and g. And f prime g minus f g prime all over g squared. So when we do the derivative, we just got to be careful here. So we get x squared y cubed. That's the derivative of f times g minus f times the derivative of g all over 3x plus 2y squared. So let's take our time and work out the derivative. Now notice that this is in itself, this is a product, so I have to do the derivative of this. So let's pretend I got f and g for these two, but let's just do f and g on this alone, not to get confused. So this is a product, so I got the product is f prime g plus f g prime. So when you have a product is the same as the division. Division got a minus sign divided by g squared. But when you have a product, you have a same order, but there's a plus sign. Notice that? So that's why I do f prime g, f g prime, because the two of them are same order, but the division is a minus sign with a denominator squared, and that's the product is just a plus. So we got x, so I'm going to do a big bracket like this now. So there's the derivative, and plus x squared y cubed derivative. So that's the derivative that I'm going to do here, times 3x plus 2y minus, and the derivative of this binomial, derivative of 3x is 3. Derivative of 2y is the same as an x. Derivative of 2y is 2y y prime. When you do the derivative of y in terms of x, you will get a y prime. And that's all over 3x plus 2y being squared. Now we have a derivative in here to do, so let's do the big brackets. So the derivative of x squared is 2x y cubed. X squared. Derivative of 3y is 3y squared y prime. Again, you do the derivative of 3y in terms of x, so pretend that's an x. So that's 3x cubed, but instead of x, you got a 3y squared. So the derivative of 3y is 3y squared and y prime. So we get 3x plus 2y. So that's, I did that deliberately to have a product within a quotient, because in calculus you don't know what you're going to get. You always got to be on the alert. And the more practice you do, the better, normally the better you get. Now I have to multiply this out. So I have to do, let's multiply this, and then spread that. Oh, I better make that longer than that because I don't have it long enough. Let's spread that right out, and then spread it out here. So I got to be careful. Spread it out. Here we go. Now I'm going to take a bit of whitener. Apologize for that. I got that bracket too short, and I don't want that. I don't want to have that hanging around. So let's use my magic trick when I make a mistake. Cover it up with a whitener. Here we go. So hopefully I can fit it all in there. Here we go. So what we have is 2x y cubed times 3x. So that's a 6x squared y cubed. Now I'll take 2x y cubed times 2y. So that's a plus 4x y to the fourth. Now I multiply x squared 3 y squared y prime times 3x. So that's a plus 3 times 3 is 9. X squared times x is x cubed. Y squared y prime. Just got to be careful. Now I go this monomial times 2y. So 3 times 2 is 6 plus 6. I got an x squared. And I have y cubed y prime. Just got to be careful. So that's done. Now let's do this multiplication here. So x squared y cubed times 3 is 3x squared y cubed. And we have x squared y cubed times 2y y prime. So 2 times 1 is 2. X squared. Y cubed times y is y4 y prime. And we have that all over 3x plus 2y being squared. Now we have to do the subtraction. So there it is. The denominator is okay. So we have to subtract. So it's the same terms here. 6x squared y cubed plus 4xy to the fourth plus 9x cubed y squared y prime plus 6x squared y cubed y prime. And we're subtracting, so we add on the opposite, or multiply by -1. Negative 3x squared y cubed minus 2x squared y4 y prime. And we got 3x plus 2y squared. Now, because we have all this, do we have any like terms? Do we have any like terms? So x squared y cubed. There's an x squared y cubed here. So this one and this one becomes 6 minus 3 is 3. So we got 3x squared y cubed. So I'm just going to rub those out for a second to keep track of them. Do we have any x, y to the fourths? X, no. So it's a plus 4x, y, 4. Okay, make that okay. And that one's done. Do we have any x cubed, y squared, y prime? X cubed. Nope, we don't have any. So there's no more like that, so we leave it. 9x cubed, y squared, y prime. So we that one done. And so what about this one? X squared, y cubed, y prime. X squared, y cubed, y prime. Do I have a 4 here? That's when I multiply that out. Nope, I don't have any. So plus 6x squared y cubed y prime minus 2x squared y 4 y prime. So you just got to be careful in the multiplication to make sure. So that's I just wanted to do one with a quotient and a product within the same one. So that's what we have here. And I just going through to make sure I didn't have an error here. So looks like everything is okay. Yep. And this last multiplication here, that's 2x squared y4. Yep. And we have 5 marks, so we go 1, 2, 3, 4, 5. If you have that, give yourself 5 marks. Total up your pages, and hopefully when you total up your pages, go back to the original, put your final mark, but they have over 33, divide 33 into your numerator, get a decimal, move your decimal 2 places to the right to get your percent. And that brings the end of the unit on quotient rule, and hopefully you understand how to do the quotient rule derivative when you have different functions. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.